Yeah, so last time we were talking about the reactance curves, or our main agenda was to find out where the poles are lying, and we were examining the properties of LC or the LC function. So just go back to where we were. So we were saying that LC driving point impedance function may be written in this form. So this is one of the form. It might be many form, where one of the form is look like this one, where z of s is impedance function, and when it's impedance function, and if I'm writing everything in addition, all these addition will make sure that all these elements are coming in series. So first element will be capacitor or inductor. Hmm? Capacitor, right? And this whole transfer function is look like inductor and capacitor in shunt, and more inductor and capacitor in shunt, and so on. And maybe there is one more inductor which is at infinity, whose value is k infinity, and this one is k0, 1 by k0 times farad.
We don't have odd omega terms in that.
Which odd omega terms?
Suppose that we have in numerator omega 1, omega 1, omega 3, omega 5. That will be removed in.
Okay, okay. Those were here on top. Look at this. Zeros were already there, but when we are using the partial fraction method, these will be eliminated. So this is the thing we are doing, right? Okay. Do you have any question in this? This is one of the form. There might be many ways to write same equation. This is one of the form which we are writing right now. And through that we found out the reactance, which was ranging from zero frequency to infinite frequency. There might be the case that you have zero at like at origin you may have uh, 0. In that case you will have pole at infinity, and so on, right? So this is what we learned last time. Now looking at or summarizing what we have done in LC emittance function. If function is an LC driving point function, the same thing can be made using RLC also, if you can find out resistance also in the transfer function. But if all the transfer function has just simple poles, when we are saying simple poles, they are only and only on j omega axis, there is nothing real term, then that function is LC driving point function, and then poles and zeros are alternate. Look at this. What we have made here, the poles and zeros were alternate. This reactance curve can be made this way when one is pole which is going to infinity. Look at this. At omega 2 and omega 4 are pole, and the reactance values are going at infinity at omega 2 and omega 4. At omega 0, or maybe 0 at origin, omega 3, and at infinity, all these values are 0. So this is only possible when these poles and zeros are alternate. If they are not alternate, you cannot make LC driving point function whose reactance curve look like this one, or it may not be synthesizable. Even if they are positive real function, they may not be synthesizable in the form of LC. It might be synthesizable in another way, maybe RL circuit or maybe RC circuit, but it may not be LC, right? So this was the first property, or the silver bullet, that the poles and zeros has to be alternate, and if there is a zero frequency at origin and at infinity, then these kind of frequencies are known as external critical frequencies. If I am saying external critical frequencies of my circuit are at zero frequencies, means zero frequencies has origin and zero frequency is at infinity. because it at external critical. However, other frequencies like omega 1 or like omega 2, omega 3, omega 4 and other frequencies which is between 0 and infinity, all other frequencies are known as internal critical frequencies. Whereas origin and infinity, it's known as external critical frequencies. This is also external, this is also external. These are some standard words which you are going to see maybe in future if you are learning communication engineering, right? Okay, let's one more time. Let's look at the LC impedance or admittance properties. If they are not following these properties, then it cannot. It may be positive real function. First of all, we are going to check whether function is positive real function or not. If it is positive real function, it will follow three properties. One property says that all the poles and zeros will be on left half plane. B, it has to be Hurwitz, and C, it has to be m1 m2 minus n1 n2 greater than or equal to 0. So if it fulfills all these properties, then you are going to start realizing the transfer function in the form of circuit. It might be any circuit. What we are studying right now, which is two kinds of only elements, which is RC, RL and LC. This is what we are studying in this course. So we are finding out which kind of admittance or impedance function that one is. If it is LC, then it will follow these five properties. If it is failing to fulfill any one of the property, then you should not use LC impedance. It might be RC or RL. So what LC impedance is saying? LC impedance is saying that the ZLC or YLC will be the ratio of odd to even or even to odd polynomials. When I'm saying this, it says that m1 by n2 or n1 by m2. This we have derived from m1 m2 minus n1 n2 greater than or equal to 0 by keeping this with some two subcategories where in one case m2 is equal to 0 and one case n2 equal to 0, right? So we can find out that thing. So if this is the case, then and then it's LC impedance function, otherwise it's not. Second part says that, which is already known to us, poles and zeros has to be simple and should be lie on the g omega axis. If they are not simple, when we are saying simple, it's like s square plus 4. The roots are plus or minus j to omega, means this is lying on j omega axis. It does not have any real part, means you can realize this with L or C. This is the meaning of this. When it has only and only real imaginary part. So that's why it's very important to have these poles and zeros simple. If they are not simple and if there is a real part, means there is a resistance. Somewhere you need to keep resistance, and in shunt with that resistance you can have capacitor, or maybe in series you will have capacitor, depending on what kind of function it is, whether it is impedance or admittance. Are you following this, right? Okay, so poles and zeros interlace on the g omega axis. When I'm saying interlace, means poles and zeros has to be alternate. So if there is one pole, then the next has to be 0. If there is a transfer function which looks like this one, then you cannot realize this with LC. Of course, it's positive real function, it's synthesizable, but not with LC. Okay, maybe some other technique which we are not studying for the limitation of this course, but you can derive everything from what we are studying, right? So this is not realizable with LC. One more thing, the highest power of numerator and denominator must differ by unity. The lowest power also differ by unity, right? And there must be either a 0 or pole at origin and infinity, just to
The transfer is like s by x plus y.
This is alternate, right? This is alternate. One zero and one pole. Yeah.
No, but you told that zero must lie on the geometry axis.
But there is one. It's already okay. So it's equal to zero plus zero j omega, right? It's also on j omega axis.
The S is equal to j omega 1.
Yeah.
And you put, so it is
So there are in total we have following number of zeros and poles. One zero at origin, one here. Sorry, two here.
what is this J?
One, right? So s square equal to one. So minus
This
one.
is the pole now.
Yeah, that's pole. So that is what I told.
Yeah, this is right, but zero must lie on the j omega axis also.
So zero is also on j omega axis, right?
Okay, zero.
Zero is also like that vertical whole line is part of j omega axis. That is what I'm saying. Zero j omega is also part of j omega axis. Yeah.
So what was the problem on the S into S square plus 1 upon this?
Okay, this one they were not alternate. So first was zero, then this is another pole, then sorry zero, then pole pole. Zero zero pole pole. It's not allowed. It's violating second number. Sorry, third number property.
Interlace means alternate.
Alternate, right? So I kept like few examples. You have to tell me whether it's LC impedance or impedance functions or not. You have to look at five different properties. By the way, just I'll give you a hint. All of them are not LC impedance functions. You have to tell that which property they are failing to match. So, so first property says that ratio even to odd or maybe odd to even. Second says that simple and on j omega axis, right? Roots. Third one interlace, or you can same thing you can read at alternate, right? Power difference and okay, for your information, let's understand only because these three are difficult. So I kept three functions which are not going to match these three. So first one, is it even with odd? It's odd with even, right? Numerator is odd and denominator is even, so it's LC. Yes, its poles and zeros are including this zero which is at zero, right? So it's also simple and on j omega axis. Are they alternate? No. So it's failing. Failing with third particular property. What about the this one?
The poles are not simple. Zeros are not simple.
Okay, so they are following. They are not matching with second property. What about last one? First property. It's failing with first property. So you can check whether they are following LC impedance function or not, because you will not be like you will not be asked generally. It's not the question. Generally, what people are asking, synthesize this impedance function. So you have to check whether it is LC, RC, or RF. Look, when you are studying LC, then it looks easier. That look, it's LC, so you can synthesize it very easily. But if it is not known to you, then you have to check the property. If you know which kind of function it is, then it's very easy. It's very easy. You can synthesize it with using any technique, which I am going to tell you. Okay. So because of these properties, it's failing. That is what kept here. Now, can you check this property for property check for this one? So first property, odd to even, even to odd, right? It's there, no problem. Second, all properties are there. So this was just for, and this was the reactance curve. So all these pole 0. By the way, have I ever taught you that this is pole and this is 0 notation? Okay. If I have not, then please. This is the notation for pole and this is the notation for 0. Right? Are you studying electromagnetic theory or something? Like in school time, have you studied these kind of symbols?
Like dot and cross.
Dot and cross. If lines are coming from, right? So if it is coming from like this, then it will be theory top this way and you can see cross, right? And if it is going in, you can see a hole. That's why it looks like 0. It's it's a top view, by the way, right? That's how it has been derived. Anyway, so now you know how to make even LC ladder realization also using any technique. If I am asking you to draw the circuit, you can draw the circuit with any way, and maybe you will not get unique answer. You may have different 20-30 answers, right? But to channelize everything, there is one guy called Foster in 1924. He found out that using partial fraction method, if I am trying to synthesize impedance or whatever I have written, this one, if I am supposed to get this kind of partial fraction which is equivalent to the this transfer function, then that technique is known as Foster 1 technique. So using this, whatever circuit you are deriving, that whatever circuit is this one, if you are deriving this or designing this in impedance, if it is admittance, then the whole thing will be changed. If this is admittance, then everything will be in shunt, right? So that one is known as Foster 2. So Foster 1 talks about impedance in this form. Foster 2 talks about admittance in this form. Both will give you different results, because if you are drawing the Foster 2, it's going to be look like, so let's assume that this is Y. Then first element will be inductor, capacitor. No, it's inductor. It's inductor, right? And as all these terms are in like with plus sign, they will be in shunt. So similar to impedance, where this was giving the shunt combination of inductor and capacitor, this is going to give you the series combination of inductor and capacitor, and so on. It might be you will have capacitor at infinity with the value k infinity, and this will be k, right? So this is Foster 2 and this is Foster 1. So this, just to make the unique answer, as I told you, the answer was not unique earlier time. So just to get the unique answer, there is one scientist at Bell Laboratory. You know what Bell, right? Mostly all the invention happened at this particular laboratory, right? So even it's Graham Bell or anyone, name the one, all like majority is from here. Okay, so he found out that I'm going to find out two kinds of network. One is Foster series network and one is Foster parallel network. Later on, people have named them as Foster 1 and Foster 2. So Foster 1 is dealing with impedance and Foster 2 deals with admittance. The function is same. The function is same, which is so if this is impedance, then everything is in series. So we are going to call this network as Foster series network, and same transfer function you are writing in terms of admittance, then all the all the terms are coming in shunt. So we are going to call that network as Foster parallel network. So both are synonym. Some people write it down Foster 1 and Foster 2. Some people call it Foster series network and Foster parallel network. Some people also call it parallel shunt network. Right? So let's move further. There may be another way to realize it. Not this way, which we have drawn just now. You can make or you can realize your impedance function or admittance function this way also. So it's not this way. Earlier one was this one. This is Foster 1 and this is Foster 1, this is Foster 2. There might be third technique also through which I can find out this one. When, look, you people have tried this one also earlier. If you remember, you when you have a transfer function, you used to write down in this form also, if you remember. Right? You have tried this one also. This is going to give you impedance and impedance will give you inductor. This red entry is inductor and green entries are capacitors. Right? But if I am writing same in admittance, then it will be reverse. Means I can do this one also. So this is another technique where you can realize your circuit, which will be inductor capacitor or capacitor inductor also. So you can do all these things through the technique that was derived by Coyer. It is also like after invention of this realization of impedance by Foster, it was in 1926. So in 1926, he has found out there are two different methods, but he is not going to use partial fraction method. Why I am talking so much about partial fraction method? Because this is the technique through which you are going to find out K1, K2, K3 and K4 and so on. You can use your technique, no problem, if it is super fast. If it does not work, the faster technique in my opinion is called residue theorem. All these values K1, K0, K2, K3 all are known as residue and can be found out by the residue theorem, right? And whenever you are doing this, it's a partial fraction method. But as you are seeing here, this kind of thing is known as, what do you think? What is this technique is known as? Continuous fraction. So in this technique we are going to use continuous, okay, right. So we are going to use continuous fraction method, through which you are finding out all the all the polynomials, and you are going to make the network inductor and capacitor only. So if it is, by the way, this all these techniques, both the techniques or previous Foster 1 and Foster 2 and Coir 1 and Coir 2, this technique is applicable to passive network. It can be extended to active network, but there are some limitation. But you can see that there is a word written here. It's applicable to passive network without missing anything. The information you will have every time correct circuit with these four techniques. So he also gave coil 1 and coil 2. Let's revisit how Foster 1 look like. So Foster 1 will have impedance. So it's technique for impedance, and this is going to use partial fraction, right? And this is series or shunt kind of uh, function. Foster 1 series or shunt? Series, because all these elements are coming in series, right? When I'm going to draw this, is there anybody who could not understand how to draw this network, sorry, this particular function in the form of inductor and capacitor? Is there anybody who wants to understand this? Are you following this? Can you draw this here? Yeah, can you draw here? Yeah, on board. Hey, draw, no problem. Like we all are friends. Look. Because this is what I learned last time. Some of the people are not confident enough, or whatever they are drawing, they thought that it's wrong. I don't know. Yeah, it's here. So whichever place you like, this side, that side. Okay, stop yourself there, and can you write down the values here? So first one will be K in F Henry. The second one 1 by K0 Farad. 1 by K0. Right? That's very important. This is the mistake we are making. Right? Now what about these two? This will be helpful to you, right? Yeah. Look at this. The unit of this one is ohm, but when it's going in 1 by, it becomes admittance.
K and
Is he has written correct, or
We're using that connector.
it's there? Himanshu, can you help? Yeah. So is it correct or wrong? Wrong. Look at this. Look, what's your name? Sorry,
Arun.
Arun. So Arun, this one is admittance. So first thing is inductor or capacitor?
Capacity.
It's capacitor, whose value is 1 by K1. So this is capacitor. This is inductor, whose value is K1 by omega 1 square. Both the things are actually added. So both the things has to be shunt in the case of admittance. So I am going to keep this thing here with this value k1 by omega 1 square and 1 by k1 farad Henry, right? Okay, thank you. So sometimes we make mistake in looking at these numbers, and your answer is wrong. Although you know it, but this is how like this is very useful chapter in the case if you want to get some uh, like offer in some competitive exam like IES or maybe GATE exam, right? So this is very important thing, and you have to get the answer very quickly. You don't have much time. You have to go with the ABCD.
Sir, I
Yeah,
think it's reversed. 1 by K1 with Henry should be there.
yeah. So this is a capacitor 1 by K1 farad.
No, reverse.
No, no, that's correct, right? Yeah, that's correct. I annotate these values at wrong places. That was the thing. Right? So this is Foster 1. Similar to that, like this is the answer, and it's matching also. Look, it's matched. I took it from somewhere from Wikipedia. These these things because it was not given in our book. So just to make sure that what you are learning it's in Foster 1, Foster 2 forms because that way it's not given in our book. Okay. Now Foster 2 is same thing. Just you are renaming the transfer function from impedance to admittance. Now somebody can volunteer now for this one to get the answer. Yeah? You can you volunteer to just draw the network Foster 2 with the values? You can take help from your friends also.
I will come there.
Yeah, yeah, you it is there. You can use the duster also. So Divanshu, what do you think? First element is inductor or capacitor? Note that this is yeah capacitor. This is admittance, so it has to be capacitor, right? You can see that. Second block is capacitor or inductor. What about third one? Yeah. So we are stopping ourselves here. So it's same thing. So first one will be K in F time. So it's farad. This is 1 by K0 prime Henry. Now you have to find out this one because here admittance becomes impedance and impedance becomes admittance. So the units are getting changed, right? Yeah, Nikita, what do you think? This value, you can help Divyanshu. So from here, I cannot see anything. That's why you people have to help me whether he is in right direction or not. Correct, Divya is doing correct. I'm not able to see from here. Look, there is a reflection. So did you get same answer which I have drawn here?
Until here it is same.
Okay, values are correct. Are you seeing same values or different?
Same.
Same. Okay, these two. What about inductor and capacitor? So you can see this. Maybe it will be useful to you. So this is admittance. So when it's 1 by, it will become impedance, and this addition is going to translate this transfer function in series, right? So you have to find out whether this one is inductor or capacitor. It's inductor. If it is inductor and this one is capacitor, so Divyan should now tell me what is the value of inductor. 1 by k1 prime Henry. Do not forget to keep the unit. K1 prime by omega 1 square farad, right? Did you get any difficulty, or this is correct?
Right.
Okay, maybe I can. Did you see same? Okay. Yeah. Yeah. So it's not positive real function. It's not synthesizable. Will not reach here. Right? Yeah. So one more time. Let's say I removed these entries. So can you tell me? Yeah. Divyanshu, can you help me in finding out inductor and capacitor value? You can sit down from and from seat you can answer it. What will be the value of inductor and capacitor?
In here now,
In here, yeah.
1 by k1 of inductor.
1 by k1 of, no, it's capacitor. One more time, please sit down and look at this. I know you are getting mistake in inductor and capacitor. That's why I'm asking you. Are you following, right? Yeah. So you can help. Maybe Divyanshu. Yeah, Divyanshu. Look, this is Z. Till that he does not have problem. Drawing this is not a problem. Values are a problem. Look.
That is written basically 1 by no, so that is
Yes. Yes. But
if you write like writing impedance separately, then it will not get it.
okay.
In the form of elements. So if you
Okay.
write y equals to like that.
Okay. If we are writing y equal to this one, then okay, you are saying this one. So if I am writing, look, Divanshu, so by the suggestion of your friend, this is admittance. Now tell me. So what is the value of inductor and capacitor? First one is inductor or capacitor?
It is a capacitor.
What is the value?
1 by
1 by k1 farad. What about this one? K1 by omega 1 square. Right? Okay. So you know how to make Foster 1 and Foster 2. No problem. If I'm asking you to realize the circuit using Foster 1 and Foster 2, both will have different answer. But if I'm asking you to draw specifically Foster 2, you all will have same answer. Foster 2 is known as parallel or shunt impedance, right? Now, third one is square 1, where it is again Z of S and the first element is inductor. And the second element is capacitor, although the name of such kind of network is not given, but just to remember from my side, if it is coil 1, I call coil 1 at back of my mind LC, and coil 2 I call CL. So the first element will be L, second element will be capacitor. In coil 2, first element will be capacitor, second will be inductor. Right? So that is how it goes. Right? So coil 1 form will have all such entries. So now somebody from girls, can you help me? Nikita, can you draw this network? Look, every time writing impedance will be difficult. Look, impedance, admittance. You have to write in your mind, I believe, or you have to train yourself that is admittance. So answer is easy: inductor and capacitor. Inductor and capacitor. It has to be there. Inductor. this is impedance, so the whole function will be in series. So this is like the whole thing will be in series. I'm going to keep it here, right? This one is capacitor, but this is the, this part was impedance, but this part becomes admittance. Admittance having the sign of series means this thing is coming in shunt with that. It cannot be series. So when I want to keep it in shunt, I need to keep that transfer function here, right? So you will have inductor, but next transfer function is impedance, so this will go in series, and the next one will go in parallel, and so on, right? So if you draw that in a better way, you are going to see inductor, capacitor, inductor, capacitor, and so on, right? Are you following this? Or because sometimes it looks confusing, just you have to remember wherever you are seeing the plus sign, whether it's impedance or admittance, right? So what is the value of inductor? Sorry, I'm not going to now. So what will be the value of inductor? K in F farad, sorry, Henry. What about this capacity? 1 by K2, K2 farad. Look, got it. Okay, then fine. Okay, what is next? K3 and K4 and so on, right? So there is no reciprocal entry over here, right? But if it is in different form, there might be the change. Okay, so coil 1 is again not a problem. You can draw that. Okay. Now, this one. Do you want to try this? Anybody? Or is it easy? Should I go forward or? Hmm? Okay, please. Yeah, can you? I forgot your name. Sorry. Webo. Webo, can you try? Okay. Okay. After doing it in copy, please do it here on, on the board. Right? Okay. Amol is already becoming expert, so. Yes. Mahima, any confusion or? Last one. Please, you have to tell me this. Yeah. Okay. Here. Okay. Which was different. Okay. Let's assume that I want to draw this one, which is impedance function. First entry is inductor or capacitor. Inductor or capacitor, I'm asking you. Inductor. Okay. Now we know that this unit of this one is ohm, unit of this one is also ohm. So the entire thing will be in series. Series means the negative terminal and maybe other terminal will be like, it will not go to zero directly, right? So the whole transfer function, let's call this one as Z2, this one is Z1 of S, this is Z2 of S, both will be in series and maybe come back, right? From this side, if I am looking Z of S, it's addition of two transfer functions, Z1 of S and Z2 of S. But now, what is Z2 of S? Z2 of S has been converted to admittance. So the first entry, which is here, this becomes capacitor. So I am keeping capacitor over here. And I am looking at the second entry, whether it's coming in shunt or series. So it's coming in shunt because this is in admittance. So this thing is also at admittance and it has to go to in shunt, right? When I am doing this, this entry becomes this entry yeah. So this entry becomes impedance, which is of inductor, right? Q3S, wherever you are seeing j omega L, it's inductor, and other thing will be in series. So I am going to keep this in series of this one. But this is admittance, this is a capacitor, go on, right? So if I redraw this network, how this network will look like? The, the capacitor's negative plate, both the negative plates are shorted with maybe minus terminal of this one. But if in case I am having 1 by Q5S, then this is going like this is admittance, which is going to be in shunt with new entry, so it has to be here with the inductor, right? If I am adding one more capacitor, it's going to be here, right? It looks sometimes complicated, but you have to do it on your own, then and then you will learn it. That's why I'm trying to ask you to practice here, right? Okay, not here. Okay, so Mahima, can you draw this one on board, right? So that she can practice, and then today we will like we call off for today's lecture, and then tomorrow onwards we are going to draw the foster one, foster two, right? So synthesize it. We will solve some of the questions like 2 or 3 questions. Right? If you want, we can do it more also. Right? Yeah. So look at this. This is also impedance, or it might be admittance. So if it is admittance, then also it will follow coil 2. But as I told you, coil 2 is CL. Right? Coil 1 is LC. So first element was L. So here capacitor in series with Z2, but this is Z, this is Y, this is Z. So here there are 2 entries. You are confused over here. Both are impedance. They have to be
So both should be
in series.
high impedance.
Yeah. So just you have to find out second term is capacitor or inductor. That can be find out by one fact that this is admittance. So this is inductor, right? So you can keep one inductor there, and you can keep in parallel of another inductor, and you can take this back to negative terminal of this one. That yeah, so that has to be come back, right? All the circuit has to be completed. So if you are looking into this system, the driving point function is this capacitor in shunt with this one, and inside you can see rest of the things, right? So if I am redrawing this, yeah, if I redraw this, it looks like this one. Let's call this one C1 L1, C2 L2. So C1 L1, C2 and L2. Right? Okay. And if you have doubt, you can ask me. Still, if you have doubt. So, as a concluding remark, if it is foster 1, inductor capacitor, and then there is series combination, sorry, shunt combination, but they are in series. So, this is known as series, and it has to come back actually. Foster 2, it's in shunt or in parallel. So all the elements are in shunt, but right, this is foster 2. Coir 1, as I told you, it's, you can think about LC. So first element is L, second is C, third is L, fourth is C, so on. Right? If in case in your circuit you are only having 3 element or the third order system, you are going to see only this one. Then this circuit is that stop here itself. If your circuit has 4 elements, means fourth order circuit, then you are going to see this, right? Similarly, if it is coil 2, it's Cl and the first element is C, the next is L, then C, L, and so on, right? So that's how, like, you can draw foster 1, foster 2, coil 1, coil 2. So I realized like coil 1 and coil 2 looks little bit difficult, so I'll keep more problems on coil 1 and coil 2 maybe this Tuesday, right? Okay, fine.